This program was designed to answer a question that came up during a conversation with a friend of mine. He had his solar panel system installed in the winter on a rather low-angle roof, 12 degrees. He told me that the output is very bad, but the technician said that the system would produce more power in the summer compared to panels mounted with optimal angle, which is 47 degrees at his location. For me, this problem was not so obvious to answer. I thought that with a higher tilt angle, the solar panels would produce less in the summer, because the sun goes higher and the angle between the sun and the solar panels is smaller. To answer this, I made a program in LabVIEW. First, I had to figure out a way to calculate the sun's position with a rather high resolution. Then I had to solve the projection problem, calculate the area of the solar panel that is illuminated perpendicularly. For this I used quaternions, which took me quite a lot of time to get used to working with. Then the user interface was quite easy. Let's see the result. Let's set the orientation of the panels to 160 degrees. It means it's almost facing south. Let's set the tilt angle of the panels to 12 degrees. Use a solar panel with an efficiency of 20%. You can also change location data here. Let's start the calculation. On the first graph you can see the ratio of the perpendicularly illuminated surface area of the solar panel compared to the whole surface area of the solar panel. This calculation was done for every minute in a year. You can see here somewhere during the summer there is a moment when the sun rays hit the solar panels perpendicularly. On the second graph the generated energy is visualized. You can examine the energy generation daily, weekly, or monthly. It means that if every condition is perfect, like no cloudy days, no solar panel temperature dependency, etc., the system could produce this amount of energy. You can see here how the generated energy is changing throughout the year. On the last tab you can analyze the output power and the generated energy for each day. Let's see the output on day 30, which is end of January, and day 180, which is end of June. Let's change the tilt angle of the solar panel to 47 degrees and rerun the calculation to see how the output is changing. Interesting thing you can see on the lower graph. The generated energy has two peaks, at around day 90 and day 250. The previous setup with lower tilt angle had only one peak during the middle of summer. So actually the technician was right, my friend's system will produce more in the summer. However, the overall energy his system can produce is less than with optimal solar panel tilt angle.